A modern home with an intact metal roof gleaming in the afternoon sun. Yet inside, a persistent water stain is quietly spreading across a ceiling. When the exterior shows no dents, missing panels, or visible holes, homeowners naturally assume the barrier is holding. This creates a psychological trap. A minor water spot on the drywall appears, but the roof looks pristine from the driveway, leading to the decision to wait and see if the problem worsens. The engineering of a residential metal roof relies on an assembly of distinct, moving parts. These components form a dynamic mechanical system where the performance of the entire roof depends on the integrity of every individual connection. This 3D model reveals the true anatomy of the system. We have the outer metal panels, thousands of mechanical fasteners, the underlayment moisture barrier, and the structural wood decking, all layered together. While the metal panels can last half a century, the intricate components connecting them face constant direct exposure to the elements. Over time, sun, wind, and temperature fluctuations wear down these microscopic connection points. Water exploits these tiny breaches long before the damage is obvious. Surface-level inspections frequently overlook the early symptoms of failure, as the most critical wear is often too small to see from the ground. To find the actual source of most leaks, we have to look closely at the smallest, most repetitive component on the roof, the mechanical fastener. Every day, these screws are subjected to thermal cycling, a kinetic force driven by the shift between hot afternoons and cool nights. Under the midday sun, metal panels absorb intense heat and physically expand, pushing outward in all directions. As the air cools after sunset, those same panels forcefully contract back toward their original dimensions. This cross-section illustrates the result. As the panel expands and contracts, it slides horizontally. This friction pushes upward against the screw head. Over many weather cycles, this stress acts like a wrench, backing the fastener out of the decking. This movement strains the critical secondary seal, a tiny neoprene washer wedged beneath the fastener head. Direct, sustained ultraviolet radiation breaks down the chemical bonds of this polymer washer over time. The pliable neoprene dries out, flattens under pressure, and begins to crack. Even though the surrounding metal panel remains intact, the ruined washer can no longer block moisture. Capillary action then actively pulls rainwater upward through the cracks in the washer and down into the open gap left by the backed-out screw. There is no crash or missing panel. The breach is entirely silent. Natural environmental forces turn the very hardware designed to secure the roof into an active channel for water intrusion. This same mechanical stress applies to the larger geometry of the roof, specifically along the panel seams and transition zones. A house is not perfectly static. Structural settling and wind vibrations send kinetic energy across the rigid panel seams. This localized stress bends the overlapping metal, creating micro-separations along the joints that are impossible to spot from the ground. Wind-driven rain hits the roof horizontally, pushing water upward against gravity, where it exploits these tiny openings in the seam barriers. The risk multiplies wherever the roof changes direction. Chimneys, skylights, and vent pipes are the most common sites of system failure. This schematic illustrates the challenge. The heat map shows the metal border expanding rapidly under the sun, while the wood remains static. Over time, this unequal movement stretches and eventually tears the sealant joints bridging the two materials. The constant pulling bends the metal edging and flashing until they pull away from the intersection. Water flowing down the slope hits these flashing gaps and cascades directly underneath the primary roofing panels. The architectural complexity of the roof dictates its vulnerability. The intricate intersections are far more likely to fail than the flat panels between them. Once water slips past a backed-out fastener or a torn flashing, where exactly does it go? It hits the hidden secondary defense layer, the waterproof underlayment rolled out beneath the metal. A water stain above a bedroom does not necessarily mean the roof failure is located squarely over that ceiling. This X-ray cross-section maps the actual path of the water. Moisture enters at a flashing point near the top of the roof, runs down the long slope of the underlayment, and drops through a decking seam 10 feet away. Wooden rafters and framing members can intercept this moving water, acting like aqueducts that channel it even further from the original entry point. The underlayment is designed to shed occasional condensation, not a chronic flow of rainwater. Constant exposure degrades the material until it can no longer hold water back. Trapped moisture then sinks into the structural wood decking, breaking down the fibers and initiating rot. Simultaneously, the humidity pooling beneath the panels accelerates corrosion, rusting the metal from the inside out. By the time a brown stain appears on a living room ceiling, the water has likely been navigating this subsurface path and damaging the structure for months. An interior drip is a symptom. The origin point is usually yards away. Treating the ceiling stain without tracking the moisture path backward results in a temporary fix. Understanding this process resolves a major fear. An interior leak does not automatically require a total roof replacement. Because the roof operates as an assembly of individual parts, the failures are often isolated. If you intercept the moisture early, a leak usually represents a localized component failure rather than systemic structural destruction. A targeted repair directly addresses the mechanics of the failure. It involves resecuring fasteners, replacing degraded washers, and applying modern, flexible sealants to aged flashings. Replacing a few specific components is a minor correction compared to the massive expense of rebuilding rotted decking and replacing entire panel runs. Professional diagnostics look past the surface. Experts physically measure fastener torque, test the elasticity of sealants, and track hidden moisture paths. A driveway visual scan cannot reveal the mechanical condition of the components holding the roof together. To find out exactly what is happening beneath your panels, click the link below to visit CamarilloRoofRepair.com. Schedule a thorough, professional inspection with Roof Repair Camarillo. Secure your perimeter now, before the next cycle of weather forces those hidden moisture pathways deeper into your home. Proactive inspection intercepts wear at the component level. It turns a minor mechanical fix into the prevention of a major structural crisis.